And now it's time for the latest exciting episode of Doz's Television Workshop.
Hello and welcome back to Doz's Television Workshop, where today we're going to be taking a look at this Oric-1 computer that I bought from eBay. Let's get into it. So here it is, the humble Oric-1. This purports to be a 48K model, and yeah, this is the computer I sort of first had as a kid. I must have been, I don't know, 13 years old, something like that, 12, 13 years old when this came out. And our next door neighbour David had one, and he was a cool kid. He had CB radio and all manner of fun things back in the day. And yeah, so I naturally copied what he did. And he was a bit older than me, and bought an Oric-1, or got an Oric-1 for Christmas, more likely. Yeah, it was a sort of Spectrum competitor, really. It was made by Tangerine Micros, Tangerine Electronics, and very popular in France, actually. Not so much in the UK. I think they ended up going spectacularly bust. But they produced a lot of stuff in France for, yeah, sort of view data terminals and things like that. There was a later model, the Oric Atmos, slightly different and I have to say less buggy ROM, and a full proper keyboard on it. This got berated at the time, but I always found this was all right. I thought it was much better than the Spectrum's offering. This one, as we can see, has got a little bit yellowed. The return key and the 7 key seem to be all right. But you can see the difference there between the top and the bottom, where it's yellowed. We might try giving it a bit of a birthday and seeing if it retro brights. It's not the time of year for sun bleaching, which is obviously my preferred method if you've watched the channel for any length of time. So we might try giving it a little bath in, I don't know, hydrogen peroxide or something. But yeah, I bought this from eBay, untested. I paid far too much money for it, and we all know what untested means. And it did come without its power supply. The power supply was just a sort of wall wart type power supply, and it was linear because it was the 80s. And yeah, they were fine. And it's just a 9 volts into that jack there. We've got a printer interface, an expansion port. I can't remember which way around this is, but we've got an RGB output and a cassette interface, and I think it's that way around. I think that's RGB and I think that's cassette. We've got the obligatory UHF RF output there. Underneath we have a reset button, which is recessed. You need to push it with something, and I will, if we get this going, I will explain something I saw on a YouTube video a few months ago that did make me laugh. Yep. 6 screws. I'm not sure if there's supposed to be a rating plate or something in there. Yeah, I suspect it's been apart sometime in its life. There's a pot there to adjust something and a trimmer there to adjust something. I seem to remember the trimmer had something to do with the colour. That might be volume. Don't know. Can't remember. It was a long time ago. So, right, yeah, bought this untested, and no power supply, so I'm going to hook it up to the workshop power supply, get a telly in here, and we'll test it out, see if it's any good. Right, first things first though, let's just drift over and have a look at the schematic, because the power supply is worthy of mention. Right, this is a copy of Oric Owner's magazine from back in the day, where we've got quite a reasonable drawing of the power supply. You can see the URL out there, defenceforce.org, computing, Oric, library, blah, 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 blah. Yeah, so this is Oric's power supply. So we've got our unregulated DC input from our wall wart, 9 volts, about 600 milliamps. Comes in, bit of decoupling, and then, well, hang on a minute, 7905. Now, a 7905 is a -5 volt linear regulator. Everybody else in the world put one up here, a 7805, and to regulate the +5 volts. Yeah, odd. Spectrum uses a 7805. C64, yeah, that did use a 7805. But why did Tangerine choose to use a 7905? It wasn't a problem back in the day. However, it may be a problem today. So this is our +9 volts. And as you can see, that's completely contiguous to our 5 volt rail. And the 7905, what it's effectively doing is bringing the 0 volt rail 4 volts up. So the 0 volts here is 4 volts different from the negative pole of our 9 volt supply. Now, it wasn't a problem back in the day because your linear power supply here was isolated. However, it could give you a problem today with a replacement power supply if this minus rail here is referenced back to mains earth. Now, it's unlikely on this size of supply that that would be occurring, but it's still a possibility. Most power supplies of that sort of size don't have an earth pin on the plug, and you're good to go. However, if you did happen to use a power supply where that was grounded, nothing would happen. You could switch your Oric on and it would all be very good until you went to plug something in that had a ground on one of the buses. So the monitor, you'd be really unlucky if it was your cassette deck, but a monitor could have a grounded input. And what that would do is effectively try and pull this 4 volts down to ground, which would upset this 5 volts. You'll end up drawing some current, possibly damaging the micro, in fact probably damaging the Oric, probably damaging the monitor, and having a really bad day. So, you know, if you're going to replace the power supply, just make sure that there's no connection between mains earth and the 0 volts on your barrel jack. So yeah, there it is. It's just a bit odd. I can't see any engineering reason why you'd want to do this. And I was thinking to myself, well, perhaps there's a cost reason. And I thought, well, a 7905, surely the 7805 is more popular, therefore it's cheaper. So I just thought I'd go and have a look, actually. And here's Mouser. There's our, you know, ordinary 7805, and it's £1.34. And here's your ordinary 7905, and it's £1.31. It is actually a cheaper part. So, from a financial point of view, if you were making millions and millions of Orics and you were saving 4p on a part, you were making 4p more on your job, weren't you? So maybe that's the reason. Anyway, you can see here we've got a 12 megahertz crystals divided down. We've got a ULA. Let's hope that's all right. We've got 6502. We've got some PROM over here, which is our ROMs. 8912. Don't really know what that is. 6522. That's obviously the same as it is on a Commodore 64. An interval timer sort of port expanding thing. We've got 8 4164 RAM chips, and these are problematic in the Oric. They weren't of great quality, so yeah, we need to be aware of that. What's that? 2312 or 2764. 764, is that a ROM? Hanging on our address and data buses. It's got to be some sort of memory, hasn't it? So yeah, copyright Oric Products International. Obviously, if you've got a 16K one, you just won't have as much RAM populated. I don't believe there are any significant differences between an Oric-1 and an Oric Atmos other than the ROM. Oh, 8912, that's your AY sound IC, look. Little amplifier out to the speaker. I have to say, I remember the speaker sort of whining consistently when the thing was running, just sort of whining away in the background. Whether this has got some sort of PLL in it that's whining away, I don't know. What else we got of interest? 8.86 megahertz PAL crystal for the colour burst. Yeah, there we go. Anyway, it's the power supply that's odd. By the way, if you can think of an engineering reason as to why this is preferable to a 7805, please drop something in the comments below. I'd love to hear from you. Right, let's get on with it. Right, well, I've got our Oric lashed up to the lab power supply on this lead here. I'm set to 9 volts. I'm set to a sensible current limit. It's on this horrible barrel jack sort of adapter here. The TV is connected via RF, I'm afraid. There's no composite video out on an Oric. Not directly. I think there might be a bit of a mod we can do. But there is an RGB output, but I don't have any method of grabbing RGB, nor do I have the lead at the moment. I may order one. But yeah, that's what we've got. So we're going to be using RF. Now, I happen to know this TV is tuned into approximately channel 36 UHF, which is where the Oric approximately transmits at. So we should be able to see something on the screen. So yeah, let's put some power on and see what happens. There we go. All right, we're drawing quite a bit of current. The manual said about 600 milliamps, didn't it? And we're pulling nearly an amp. So let's just see what we've got on the screen. I'm not happy about that current consumption. It is fairly steady though, so fine tuning. We can just bring that in. Okay, right. We have got something, haven't we? Looks like a bit of something is going on anyway. So yeah, I think the next thing to do is actually take it apart, because it does have notoriously rubbish RAM chips. And if anything's hanging up, I mean, clearly we're attempting to execute code because we've got some sort of video generation going on. So yeah, that's pretty good. I'm pleased. That's not a disaster. I should switch off. Just disconnect. Let's get these 4 screws out of the bottom. Quite large screw heads on these. And they're quite a chunky thread on them. There it is, look. How lovely. Oh, we've got Mitsubishi RAM in there. Ooh. That one's still warm now. This has had some action, look. That looks brand, well, it all looks brand new, doesn't it? That's the relay for the tape deck. Okay. That does look in really good condition. There's our AY38912 sound IC. That's the ROM 6502, 6522. That's the ULA. Let's hope that's not faulty. But yeah, that end RAM chip is still warm now. Let's just put some power on. I'm not hearing any whine from the speaker either. Maybe the later ones were better than the original ones. Oh yeah, that's that end one is cooking. The others are all cool. Just that one. Alright, let's get the board out. Now, this should just lift off the keyboard like so. There we have it. Inspected Oric, made in Japan. Learn something new every day. There we go, and it is that RAM chip on the end. It is, of course, a 4164 dated 1983. It's getting very hot. That's the keyboard connector. I thought some rework had been done there, but no, that looks alright. Got a mod there. That all looks in really good condition, really, doesn't it? Somebody's soldered the sockets on. Maybe they were hand soldered originally. But no, that looks in really good nick. Right, let's extract that memory chip. Stick a socket in there. We've got something going on around there. Oh, that's the trim pot. I'm fairly sure that was something to do with the colour. We'll have a look in a minute at the diagram maybe. Right, let's see if we can get the thing to run first. I mean, that's as simple. Was there anything else getting hot? No, let's just get that one out first. And then I'm going to desolder this from both sides of the board, I think. Let's get the desoldering tool on first. And yeah, we'll just take that chip out. One thing at a time, eh? First things first, let's get some fresh solder in there. Now the pins have been folded over slightly, so I'm going to go in at a jaunty angle. Right, let's just see what kind of a job we've made from the top. Yeah, I'm just going to run down there a little bit of desoldering braid just to clean up any sort of excess. The board is double-sided and the solder has crept through to both sides, as you'd expect. But I just don't want to damage any pads on the way out if I can possibly avoid it. I have the IC extractor there. I just want to be a bit careful because print will be fragile. Oh. Something's hanging us up on this side. Is it that ground pin? I think it might be, because it's quite a big trace and there's sort of precious little thermal relief in there. Just angle the tweezers in there a bit, see where we're hung up. I think it might just be on that ground pin. Let's put a bit of fresh solder on it and just try again to desolder it. That looks a bit more convincing. Maybe not. Let's just run down the pins again with the desoldering gun. Oh, we're free. We are free. And have I lifted a pad? I have. Damn. That one there, I've got a sneaking suspicion that's not actually connected. IC19, 1, 2, 3, 4, 5, 6, 7, 8, 9, pin 10. IC19, pin 10. What is it connected to? Let's just have a little look at that diagram again. 19. Pin 10 is MA5. That's connected on the bottom, so that top pad wasn't doing anything. I think we're good. Right, let's find a socket to go in there and fit a new 41. Is it 4146? 4146. 4164. My bad. Right, sockets. Where are we? Is it that size? Nope. Smaller. Bigger. It's always the ones you got least of, isn't it? Sadly, I don't have any pretty turned pin ones. So we'll go with this. Direction of the chip is marked on the board, and it's the same as all the others anyway. But we will line our socket up correctly. We want a bit of blue tack. Oh, just to hold that in while I solder it. There we go. Spin that over. Solder that up. Right, one socket installed. RAM. Should have some 4146s. Fairly sure this is them. Yes, how lovely. Oh yeah, I bought these off a lovely eBay seller a while ago to do another job. 4164s. Why can't I say that? And 2 shorter legged ones for free. Tested 2012. Thank you. Lovely eBay seller. I've dealt with him a few times. Can't remember the guy's name, but there we are. So there we have a new RAM. That is absolutely brand new as well. Some of them you buy and they've been recovered off boards, but this clearly isn't, because it needs its legs squished. There we are, legs duly squished. Pop that into the computer. I'm not going to bother with the keyboard, etc. for now. Let's power back up and see if it works. RF. DC. 3, 2, 1. No, it doesn't. Oh, yes it does. Oh, that's good news. Let's see if we can clean that image up a bit. Down, 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 down. Fine tuning. There we go. Oh. Wrong button. There we go. Oric Extended Basic version 1.0, copyright 1983, Tangerine. Everything's running cool. Don't hear the speaker whine. Right, well, let's just pop it back together. Now, the Oric, every time you pushed a key, it made a click. And I think it was quite high memory serves, and this is all going off my childhood memories. When you pushed the letter keys, the ordinary keys, it gave a sort of high-pitched click, and then when you pressed return, it was a lower-pitched click. I found it quite good, but there we are. A lot of people hated it. They didn't like the keyboard. I think it was probably just jealous Spectrum owners, maybe. I'm just going to pop one screw in there for now. Say that end screw hole doesn't line up very well. Other than that, it's beautifully made, isn't it? Quality product. Yeah, how am I going to do this? I'll just rest it back in here for a moment. Oh no! Is my RAM chip socket going to give me trouble? We might have to take that out and solder it straight to the board. I think we'll be alright. It's tight. Right, Oric-1 going on. We're consuming, yes, 620 milliamps now. So, no, I've got nothing. I've got none of that key click. The other thing you could do with an Oric was it had 4 really good inbuilt sound effects. There was shoot, just as a basic command. Nope. Explode. Explode. Nope. Zap. Nope. And ping. Oh, does my P work? Yes. Ping. Right. So we have a no sound fault. Okay, well, we've got a working system in, just a few minutes, so that's a bonus. Dead giveaway from a red hot RAM chip mine, but yeah, no sound. Okay, let's drop that screw back out again. I wonder if it's something just as simple. It's a speaker being open. It's only driven by a little amplifier somewhere, an LM something or other. Yeah, LM358, I think. Old favourite. Oops. I wonder if the speaker's open. Let's just have a little look. Ohms. It's supposed to be something. We don't know. 440,000 ohms. Yeah, that's not doing anything, is it? So we may just have an open circuit speaker. Where am I going to find something to fit in there? Because this is quite a low profile thing as well, isn't it? Right, there's our speaker. Quite a low profile kind of thing, isn't it? Right. Double check. Ooh. 25 ohms. Says 25 on it there. Z25, 25 ohm impedance. Makes sense, doesn't it? And that reads good. But when we read it in circuit a minute ago, definitely looked open circuit, didn't it? Has just a bit of heat on there. Put it right. Stranger things have happened. I have to say the wires do look a little bit exposed on that coil, don't they? Let's push it back in. Quite easier said than done. Oh, there we go. There we are. Right, we're back in. Just a bit of heat on those pins. It may have just managed to solder the voice coil where it comes across the spider into the coil. Who knows? We'll find out in a moment's view, won't we? Okay. Let's just try it without the keyboard for a second, just to see if I can hear the speaker whine. Right, going on. I'm not sure as I didn't. The desoldering tool's making a row. Let's switch that off. Right. I am unconvinced. Interesting that we're getting the odd character up, but No, that is not working. Oh, yes it is. Ah, it is intermittent. There, you can hear that sort of whine. Yeah, it's got an intermittency about it. Let's just take it back out and put some heat. So let's take it out and I'll show you. That's the easiest way to do it. Right. Pop that out of there. Pop that out of there again. Okay. So these two connectors here, they're soldered here to two very fine wires that you can see just down the back of the speaker there. That's actually going onto the diaphragm, and the coil is on the diaphragm itself, and you can see those two wires there. And I just wonder, that one doesn't look quite right to me. Let me just get it under the seeing eyes and have a look. I think somebody soldered that previously. That might be how it's made. In fact, if you think about it, it probably is. They wind the coil, which sits inside the magnet, the voice coil itself, inside the magnet, and then that's going to be needed to be soldered up to these wires that end up leading back here. So, how does it measure at the moment now it's out? $25 ohms. I'm just going to try and put some heat into there quickly. Alrighty, let's measure that again. A bit variable, isn't it? I'm a bit stuck and I know what to do here, really. You know, let's just get my signal generator going and let's move it about, see if we can find out where that break is. So, signal generator on. Wait for it to start up. Right, we've got 1 kilohertz on. Yeah, nothing. Amplitude. Oh, there we go. We have some intermittency somewhere. We certainly have now. Just finding out where is the problem. It's not those wires. I've got a sneaky suspicion it's this one here. Well, I've got nothing to lose, have I, at this point? So if I just give that a quick dab with the iron, see if that improves matters. very quick dab. And that's damaged it completely by the look of it. That's definitely where it's broken though. I wonder if we can just cajole it into working permanently again. Listen to how much better that note is now. I think before, as the diaphragm was moving, it was just sort of rattling against that. Oh, I thought it failed then. It's the croc clips on this thing are useless. I must change them for some new ones. No, we can manipulate that all we like now. And that's good. What a fix. What a fix. I'm pleased with that. Right, let me just desolder these holes again quickly. Okay. RF, DC, I can hear that whine now, so yep, there we go. Don't know why that keyboard thing's doing that strange thing at the start. Zap! Shoot! Explode! And ping. Absolutely brilliant. So, yeah, other than that initialization of the keyboard, and now it's fine. So 10, we're going to do it. You know we're going to do it. Print. How do we get caps off? I got a feeling that was something like Control V. No. There was a mode to get caps off. I can't remember. Never mind. DOS. Television. Work. Shop. Shoop. Shop. So we go on. 20, go to 10. Right, now back to that video I was watching on the Oric-1 the other day, and the guy, you know, he had one and he was showing you all the features on it, and he said one of the worst features was the fact that you couldn't break out of a program because the escape button didn't work, and every time he wanted to break out of a program he was turning the Oric up and hitting the reset button underneath. No, 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 my friend. Run. There we go. Doz's Television Workshop scrolling up the screen. It is Control and C. Break in 10. Control and C. There it is. Can't remember how to change the colour. It is a colour machine. What colour is it? Paper? Oh, I've changed the colour. Oh, we have a blue cursor. That's paper? Ah. How strange. Oh, is it ink? Is it an ink statement? Ink 4? Oh, ink 5 is horrible, isn't it? Let's try ink 6. That's even worse. Can hardly see anything now. Illegal quantity error. Ink 1. Yes, it's particularly unpleasant on the colours, isn't it? Not helped by the fact we're in RF and PAL, of course, so composite video. But it's working, isn't it? Paper 1. Oh, it's done it. Paper 2. Paper 0. Oh, that's quite nice. Oh, telly's having a problem, but it's not a bad display really for RF. Right, well, we've got a working Oric-1. The only problem is now, clearly, I need to build a power supply. So, yeah, let's do that next. Right, I've just had a little trip into town to visit the wonderful electronics grotto that is NP Harding. Hello to Stephen and Norman, where I have purchased this power brick. There's no jack or anything on it, and it says 9 volts AC on it, which means it's just a transformer. So we're going to need to add some bits and pieces in here just to give us a DC output. So we've got 4 screws underneath. I don't know where this has come from. Oh, well, that's in there, isn't it? Well, that's a sensibly sized transformer, I would thought. Quick stick. Remove protective paper and apply to... Well, they never bothered, did they? Anyway, that's in there. That'll be alright. We've got a suitable output lead, which is just the job, really. First things first, I'm just going to desolder that from the transformer. There we go. And what we need to do is add in a bridge rectifier and a bit of smoothing in there. So this transformer looks like it'll adequately supply our required 600 milliamps. I'm just going to see what bridge rectifiers I've got. Bridges. What have we got? Oh, that's what I want. Now, I was measuring about 650 milliamps. So our bridge rectifier needs to cope with that. This is a W08 MG. So, yeah, let's just make sure that's going to be big enough. I suspect it will be. Quick Google. What was that number again? W08 MG. 1.5 amps. Oh, so that's just plenty, isn't it? That's good news. Okay. Right. So I need to mount that in. AC goes into, the pins are marked on the top. The positive lead, you can see there, is slightly longer. It's that one there. AC is in on these two here. You can see the markings there, and our negative is there. So I'm half tempted to just sort of strap it in and support it by its own legs, really. Yeah, I think we can do that. It's either that or I'd make a little bit of strip board, maybe. What have we got? Yeah, look at that. We've got a little offcut of something there. So that's quite pleasant, isn't it? I think we'll go with that. So let's mount our rectifier on the board. Solder that into position. There we go. And we're going to want some smoothing. So we need these power supplies would have been very, very simple back in the day. So let's see if we've got something like 1000 microfarads. Be lovely. Now, these are of some vintage, so what I'm just going to do is I'm just going to put them on our power supply up there, give them a few minutes to reform. That is 1000 mic at 25 volts. I mean, it's quite a big thing, but well, let's be honest, I'm not short of space in there, am I? Give you some idea. I mean, that's 1000 mic at 25 volts. That's 1000 mic at 63 volts. More modern part, same diameter, slightly smaller. Capacitors do all vary, but I know I've had these in stock a long time. So let's just give that a quick whirl and reform it, see if it's all right. I suspect it'll be absolutely fine, but I just want to make sure. Don't know where they came from. Bought for a project or something. Don't know. Right, let's just switch the power supply back on. We want 25 volts, near as damn it. I'm going to limit the current to just a milliamp. Switch on, just let that charge up gently. We're at 5 volts, 6 volts, 7 volts. 22, 23, 24, and there we are, 25 volts. So I'm just going to let that sit for a couple of minutes. Right, I've just had a very nice cup of coffee, so we can take that power supply off of there and get these leads out of the way of the camera. There we go. Right, that will still be charged up for a few minutes, a few moments I would think. Let's just see if it's still holding its voltage. It'll appear backwards because I've got the leads around the right way, yep. It's slowly discharging, so that's good. Where's my discharging probe? Let's just put that across it, give it an easier life. Just measure its ESR in a moment, just to check it's all right. It should be absolutely fine. Just discharge that. See what we're down to. That discharging probe, if you haven't seen it before, it's just a probe with a 10k in it, I think, which is probably not going to discharge this very quickly. No, we're only down to 19 volts. Right, let's just leave that on there for a second. If you short a capacitor out, you know, and get a big bang and some sparks and some, you know, YouTube content out of it, fair play to you, but it runs the risk of damaging them. These do have, you know, a peak current rating. So, yeah, you can do that if you wish, but I don't want to damage it. It's old enough as it is. 6, 5, 4... 1.9, 1.8, 1.7, yeah, right, that'll do. Let's just short it out now. Let's just have a quick measure of its ESR. This is absolute paranoia really, but I'm sure it'll be absolutely golden. Monitoring for component. $1100 mic, ESR 0.07 ohms. Yes, that's absolutely smashing. Right, so quite sure I'm going to sort of arrange this, but it'll be fine. Let's pop that in there. Now the capacitor needs to be the next row along to make it fit. There we go. Now the capacitor needs to be between the positive and negative leads around the right way, so I'm just going to bend those over like that. Solder it up. trim the excess legs off. Want to put a bit of solder underneath there as well. So negative side is on here, which goes to the negative side of our bridge rectifier. Positive side goes to the positive side of our bridge rectifier. Need a couple of short wires to go between the AC bit. Let's get some wire out of the cupboard. I choose this green stuff. We don't want very much, are we? Have 2 lengths of that. That'll be absolutely super. Right, tack these 2 wires onto the input to the bridge rectifier. Polarity is not important here, so just tack them on willy-nilly onto the AC side. Right, solder those onto the output of our transformer. There we go. Right, now I'm just going to get a couple of clip leads and we'll just measure our voltage, which will be bigger than 9. The bridge rectifier, because we're dealing with peaks, and 9 volts is probably RMS. I don't know, this is a random transformer, so our peak will be stored across our capacitor. This will drop under load and we're going to measure that just to be fussy, and we can do something with a resistor if we just want to give the regulator in our Oric a bit of an easier time, which is no bad thing. So what am I going to want? I want a couple of clip leads to start with.
1 minute 37 seconds later.
Do you know what? Why don't we just do the sensible thing? Solder our output lead straight on there. There we go. Right, so meter is on volts DC. That's on red. That's on black. So I'm just going to plug that in. Right. Bearing in mind that's going to be live, so we don't want to come into contact with that really. Got a generous amount of mains really. There we go. Plug it in. And we have got 11 volts. That's offload. So 11.3 there. That'll probably be adequate, but just to prove the point, I'm just going to put my dummy load on there and we'll make some measurements. Be right back. Right, can you see me? Jolly good. I'm in the dark, just so you can see this screen. It suffers with terrible glare. This is the Chinese load. Very good it is too. It's got a little Bluetooth thing flashing away there. You can connect it to an app on your phone. But anyway, as you can see, this is currently switched off. We've got 11.4 volts, and I've set the current, the load current, to be 0.66 amps. Continuous current, so that's 660 milliamps, which was a little bit more than the Oric was requiring, but let's just put it under load. And as you can see, instantly that voltage has dropped because it's not a regulated supply. Yeah, and we're 660 odd milliamps there. So yeah, I think that's adequate. We're supposed to have 9 volts, we got 8.6, but I think that'll do us. Right, let's get everything tidied up and assemble the power supply and then give it a test. Okay, well, I've just cut the little PCB down. I think it's going to live in there a bit like that. And just to stop this transformer rattling around, I think we're just going to gunge it all in with a bit of yak's vomit. So yeah, let's just ease that strain relief out. I'm just going to put a smear in there. A vain attempt to hold that transformer into place. That's all dried out anyway, even if it had been attached. And then I'm just going to do the same with the circuit board because there's no real weight to it, unlike, of course, the transformer. There we go. Plenty of goo in there. Just gunge that into position. Hold that for a couple of seconds so it sticks.
10 seconds later.
There we go. Where's the lid? Put that mains strain relief back in. There's our lid. Good, that all fits nicely. No more rattles. Even better. Button it back up. We'll just check what fuse we've got in here actually. £13 naughty. Let's sack that off and fit a 3 amp I think. There we go. Happy that that's not going to burn my house down now. Right, we've got to deal with the DC end, haven't we? So I think what I'll do is I'll just lop that connector off there, a bit of heat shrink, and just solder that lot together. Let's move the glue gun out of the way. Yeah. Just confirm polarity. Right, so black hopefully will be connected to the outside. Yes, good, right. Bit of heat shrink. Looks to be about the kip of it. Yeah, I think that'll do us. Take that sticker off, I think. Right, our power supply is plugged in. Let's apply power to our Oric, see if it works. Yes! Brilliant. That all seems to be just working brilliantly. Great news. Right, one last thing to do I suppose, and that's to stick a label on there that says Oric power supply so I don't lose it. There. Brilliant. And there you have it, the Oric-1 home computer from about 1983. Definitely a place in my heart for that one. I'm not quite sure what happened to the original one. Maybe my brother's got it somewhere. But there we go. Sadly, I don't have any software for it. So I've just written a quick sort of high-res graphics demo there in BASIC. But yeah, I am investigating an SD card solution. Now, you might remember a couple of weeks ago, we did the Amstrad CPC 464. and I've sort of stuck a problem with a sort of SD card solution with that as well. Anyway, I'm hoping one project will suffice to sort of give us a tape loading solution on both machines, so that'll be good. Anyway, thank you very much for watching. Click like, subscribe, do all that rubbish, and I'll see you really soon here on Doz's Television Workshop. Cheers now, bye.
Electric dreams take shape under moonlight skies. Dazzy was ready, the vision clear. In a neon world, his future is here. In a world of bits and gold, oh yeah. Dazzy found a way to make it go, oh yeah. Chasing tech dreams with electric beams. The revolution was right here in this textile. In a world of bits and gold, oh yeah. Dazzy found a way to make it go, oh yeah. Chasing tech dreams, a revolution right here. Probably discs and tapes were stacked high. A flickering screen illuminating the sky. That's his first computer, oh yeah. Needs to be running sweeter, oh yeah. It's got bad RAM, wasn't going to plan. But does it soon fix it up? The Oric-1 attacking to his son. One Christmas morn in 1983. A missing power supply. Dozzy soon recreated 9 volts DC, adequately rated.
Do it one more time, not happy with that. Cool, that'll do. Did I not press record? Oh, bollocks.
Hello, and welcome back to Doz's Television Workshop.